Hello, in this lecture we will find the radius of the red semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle. This angle ABC equals to 90 degrees. We also know that side AB of triangle ABC equals to 4 units. Line segment DC equals to 1 unit. And we want to find out the radius of this red semicircle. So first of all, I will present to you a new rule, rule number 1, and we will implement rule number 1 in our drawing. So rule number 1, or two tangents theorem. Rule number 1, or two tangents theorem, states that the length of two tangents from a common external point to a circle are equal. So I will read rule number 1 or two tangents theorem again. Two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So the length of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1 or two tangents theorem? The meaning of two tangents theorem is that if you have a circle and this point P is a common external point, an external point of this circle. Why point P is an external point of this circle? Because of the fact that point P is not located inside this blue circle nor on this blue circle, but it is located outside of this circle. Therefore it is defined as an external point of this blue circle. So if from the external point P, we will draw two tangents to this blue circle. So the first tangent will be this tangent, we will define the touching point between this tangent and the blue circle as point A, and we will draw from point P second tangent to this blue circle, and we will define the touching point between this blue circle and the second tangent as point B. So actually the length of this first tangent is PA, the length of the second tangent, this tangent, is PB, and according to rule number 1 of two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So the length of the first tangent is PA, the length of the second tangent from point P to the circle is PB, and according to two tangents theorem, the lengths of those two tangents are equal to each other, that is to say PA equals to PB. So whenever you draw two tangents to a circle from a common external point, then the lengths of those two tangents will be equal to each other, that is to say PA equals to PB. So we actually can implement rule number 1 of two tangents theorem in our drawing, because in our drawing we have the external point A of this red semicircle, and from point A we have two tangents to this red semicircle. The first tangent is tangent AB, and the length of tangent AB is 3 units, and the second tangent is tangent AE. So according to rule number 1, the length of those two tangents, tangent AB, that equals to 3 units, is equal to the length of the second tangent, that is tangent AE, because from the external point A we have two tangents to this red semicircle, and according to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So whenever we draw two tangents from a common external point of a circle to that circle, then the lengths of those two tangents will be equal to each other, that is to say AB equals to AE. We know that AB equals to 3 units, it is given us in the question. So from this equality we will conclude that AE also equals to 3 units. So AE equals to 3 units, and in the next step I will present to you a new rule, rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and the center of this circle is at this point, we will define the center of the circle as point O, and we also have a tangent to this circle actually tangent AB. This tangent is tangent to this blue circle. At this point we will define the touching point between the tangent and the blue circle as point M. Then we will join together points O and M by a straight line. OM is the radius of this blue circle, so we will call it R, radius. And according to rule number 2, a tangent and actually point M is the point of tangency of tangent AB with this blue circle. And according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So actually this radius of the blue circle, radius OM, it is drawn to the point of tangency, that is to say this radius is drawn to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So according to rule number 2, whenever you have a radius like in this drawing that is drawn to the point of tangency, that is to say this radius is drawn to point M, that is the point of tangency, then the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees. So we can actually implement rule number 2 in our drawing, because in our drawing we have the tangent AC that is tangent to this red semicircle at point E. Actually, point E is the point of tangency of tangent AC with this red semicircle. Point E is the point of tangency of the tangent AC with this red semicircle. we will define the center of this red semicircle as point O. Then we will join together points O and E by a straight line. Actually, line segment OE is the radius of this red semicircle because of the fact that it starts from point O, that is the center of this red semicircle, and ends at point E, that is a point of the semicircle itself. Therefore, OE is the radius of this semicircle, so we will define the radius as R. So OE equals to R. Likewise, line segment BO is also the radius of this semicircle because of the fact that line segment BO starts from point O and ends at point, that is the center of the semicircle, and ends at point B, that is a point on the semicircle itself. Therefore, line segment BO is the radius of this semicircle. Likewise, DO is also the radius of this semicircle because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore, line segment DO is the radius of this semicircle. So here, as you can see from the drawing, the radius OE is drawn to the point of tangency, that is to say, it is drawn to point E, that is the point of tangency. Therefore, according to rule number 2, the tangent AC is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. I will repeat again that the radius OE is drawn to the point of tangency, that is to say, it is drawn to point E. Therefore, according to rule number 2, the tangent AC is perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So, because of the fact that angle OEC equals to 90 degrees, then triangle OEC will be a right triangle because it has one angle that equals to 90 degrees. So the green triangle, triangle OEC, is a right triangle. And we will focus on the right green triangle, triangle OEC. So on the right triangle, right green triangle, triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse in the green triangle is side OC because of the fact that side OC is in front of the right angle. Therefore, OC is the hypotenuse of the green triangle. So, according to the Pythagoras theorem, the square of the hypotenuse, that is to say OC square, equals to the sum of the squares of the perpendiculars, equals to OE square plus EC square. We will define the length of EC. We will define EC we will define side EC as x, that is to say side EC equals to x units in its size. So I'll repeat again, according to the Pythagoras theorem, in the green triangle, triangle OEC, the right green triangle, triangle OEC, OC square equals to OE square plus EC square. So, what is the value of OC? The value of OC, as you can see from the drawing, is R plus 1. So if OC equals to R plus 1, then OC square will be equal to R plus 1 square. And it equals to OE square. OE equals to R, it is the radius of the red semicircle. So if OE equals to R, then OE square will be equal to R square plus EC square. EC equals to X, therefore EC square will be equal to X squared. So in total we got that OC square equals to R plus 1 square, OE square equals to R square, and EC square equals to X squared. So R plus 1 square equals to R square plus X square. Here we will open the brackets on this side of equation number 1, and we will get that R plus 1 square equals to R square plus 1 plus 2R, and all equals to R square plus X square. So in this equation we have R square in both sides of equation number 1. So we will subtract R square from equation number 1, and so R square will get cancelled, and what is left after we cancelled R square, what is left is, from equation number 1, is actually 1 plus 2R equals to X squared. So according to equation number 1, 1 plus 2R equals to X squared. So in the next step, we will focus on two triangles, on triangle ABC, the big right triangle, triangle ABC, and we will also focus on the green right triangle, triangle OEC, and we will actually prove that those two triangles are similar to each other. So we will focus on triangle ABC and on triangle OEC. Actually, on those two triangles, those two angles are equal to each other. They are both right angles, so we can write down that angle ABC, this angle of triangle ABC, equals to angle OEC, this angle, and equals to this angle, angle OEC of triangle OEC, and both those two angles are right angles. They are equal to 90 degrees. So angle ABC equals to angle OEC, and both angles are equal to 90 degrees. And we also know that this angle is a common angle, angle C, because it belongs to both triangles. This angle, angle C, belongs to the right big triangle, triangle ABC, and it also belongs to the small green triangle, triangle OEC. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. So angle C equals to angle C is a common angle that belongs to both triangles, and those two angles are also equal to each other according to third angle theorem. So this angle, angle BAC, is equal to this angle, angle EOC, and they are equal to each other according to third angle theorem. So I'll repeat again. Angle BAC of triangle ABC equals to angle EOC of triangle EOC, and they are equal to each other according to third angle theorem. So what is third angle theorem? Rule number 3 of third angle theorem. According to rule number 3 of third angle theorem, so rule number 3 of third angle theorem states that if two angles of one triangle congruent to two angles of another triangle, then the first pair of angles must also congruent. So I'll read the third angle theorem again. The third angle theorem states that if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3 of third angle theorem? The meaning of third angle theorem is that if you have two triangles, triangle ABC so this is triangle ABC, and we have also another triangle, triangle DEF. This is triangle DEF, and in those two triangles we have two pairs of angles that congruent. The first pair of angles that congruent are those two angles. This angle equals to alpha, and this angle also equals to alpha. So those are the first pair of angles that congruent to each other, and we have also a second pair of angles that congruent to each other. This angle equals to beta, and this angle also equals to beta. So those are the first pair of angles that also congruent. And if this angle is gamma and this angle is theta, so if this is the situation that we have two pairs of angles that congruent to each other in two triangles, then those pair of angles must also congruent. That is to say, according to third angle theorem, if this is the situation, then angle gamma also must congruent to angle theta. That is to say, angle gamma equals to angle theta. So I'll repeat again. If we have two triangles that have two pairs of angles that congruent to each other, then those first pair of angles must also congruent. That is to say, according to third angle theorem, angle gamma also equals to angle theta. So I will prove that angle gamma equals to angle theta. We will use the rule that says that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle ABC is equal to 180 degrees. So if we focus on triangle ABC, the sum of its angles equals to 180 degrees according to the rule that I mentioned. That is to say, alpha plus beta plus gamma equals to 180 degrees. I will repeat again. The sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, if you focus on triangle DEF, the sum of its angles also equals to 180 degrees. That is to say, alpha plus beta plus theta also equals to 180 degrees. I will repeat again. the sum of the angles in triangle DEF also equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. So here we will subtract equation number 1 from equation number 2, and we will get that alpha minus alpha equals to 0, beta minus beta equals to 0, and gamma minus theta equals to 180 degrees. Minus 180 degrees is 0. So we found out that according to equation number 3, gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we found out that gamma minus theta equals to 0. Here we will add to equation number 3 this equation theta, and we will get that angle gamma equals to angle theta. So we actually proved that angle gamma equals to angle theta, and that is exactly what we wanted to prove. We wanted to prove that if we have two triangles with two pairs of angles that congruent, then the third pair of angles must also congruent. That is to say, angle gamma equals to angle theta. And we actually proved that indeed angle gamma equals to angle theta. Okay, so actually we proved that the third angle theorem is true. Okay, so now we will return to our original drawing. In our original drawing, we actually proved that all three angles of triangle ABC congruent to all three angles of the right triangle, triangle OEC. Therefore, we actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. I will repeat again. We actually proved that triangle ABC is similar to triangle OEC. This is the sign of similar. Triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle congruent to all three angles of another triangle, then you actually proved that those two triangles similar to each other according to angle similarity rule. Okay? And from the fact that triangle ABC is similar to triangle OEC, the green triangle, we will conclude that AB over AC in triangle ABC, AB over AC in triangle ABC is equal to OE over OC in the green triangle, triangle OEC. So I will repeat again. From the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle the green triangle, triangle OEC. But what is the value of AB? The value of AB is 3 units. According to what is given us in the question, AB equals to 3 units. And what is the value of AC? That is the hypotenuse of the triangle ABC. AC equals to 3 plus x. You can see from the drawing that AC equals to 3 plus x. So in total, we found out that AB equals to 3 units and AC equals to 3 plus x units. And what is the value of OE? OE is the radius of the semicircle. It equals to R. And what is the value of OC? The value of OC, you can see from the drawing that OC equals to R plus 1. So OE equals to R and OC equals to R plus 1. In total, we got that 3 over 3 plus x equals to R over R plus 1. Here we will cross multiply equation number 2, and we will get that 3 times R plus 1 equals to R times 3 plus x. So here we will open the brackets of equation number 2, this equation, and we will get that 3R plus 3 equals to 3R plus R times x. So here we have 3R in both sides of the equation, so we will subtract 3R from this equation, and so 3R will get cancelled. And what is left from equation number 2 after we cancelled 3R? What is left? It is actually 3 equals to R times x. That is what is left after we cancel, from equation number 2, after we cancel 3R. So here we will divide equation number 2 by x, and first of all, why it is allowable to divide equation number 2 by x? Maybe x is 0, then, and if x equals to 0, it is not allowable to divide anything by 0. But as you can see from the drawing, x equals to EC, as x is one side of this green triangle. Therefore, x must be a positive number, it can never be 0, therefore it is allowable to divide this equation, equation number 2, by x, because x can never be 0 as a side of a triangle. So we will divide equation number 2 by x, and we will get that the radius of the semicircle R equals to 3 over x. So according to equation number 2, the radius of the semicircle equals to 3 over x. But according to equation number 1, we have already found out that 1 plus 2r equals to x squared. 1 plus 2r equals to x squared. So here we can substitute r by 3 over x, because r equals to 3 over x according to equation number 2. So we will do it now. We will substitute r by 3 over x. We will get that 1 plus 2r, r equals to 3 over x. So r is 3 over x. And all equals to x squared. So here 2 times 3 is 6, so we'll write it down. 1 plus 2 times 3 is 6 over x equals to x squared. So here we will multiply this equation by x, and we will get that x times 1 is x, 6 over x times x is 6, and x squared times x is x cubed. So we got this equation number 1. Here we will subtract from this equation x, and we will get that x cubed minus x equals to 6. Here we will subtract from this equation 6, and we will get that x cubed minus x minus 6 equals to 0. Okay, so here we will add to this equation 0. We know that minus 2x squared plus 2x squared equals to 0. So this expression equals to 0, and it is allowable to add to any equation 0. Therefore, we can add to this equation, equation number 1, this expression that equals to 0. Okay, so we will add this expression that equals to 0 to equation number 1, and we will get that x cubed minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. Here we will substitute minus x by, actually minus x equals to minus 4x plus 3x. So we can substitute minus x in this equation by minus 4x plus 3x. So we'll do it now. x cubed minus 2x squared plus 2x squared, and instead of minus x we write down minus 4x plus 3x that equals to minus x. Minus 6 equals to 0. So here we will divide this equation to 3 parts, and we will take a common factor from each part. So the first part will be this part, the second part will be this part, and the first part will be this part. So, as you can see here, we divided this equation to 3 parts, and we will take a common factor from each part. Okay, so the first part is actually x cubed minus 2x squared. So I copied the first part to here, and we will take a common factor from this expression. The common factor that we will take from this expression will be x squared so actually what is left from x cubed after we took a common factor x squared from it, what is left, it is actually x. And what is left from minus 2x squared after we took a common factor of x squared from it, what is left, it is actually minus 2. So in total we found out that x cubed minus 2x squared equals to x squared times x minus 2. We will repeat on the same process on part number 2. Part 2 is actually 2x squared minus 4x, 2x squared minus 4x, and the common factor that we will take from this expression 2x squared minus 4x, the common factor that we will take will be x, will be 2x. The common factor is 2x. So what is left from 2x squared after we took from it 2x as a common factor? What is left, it is actually x. And what is left from minus 4x? What is left from minus 4x after we took 2x as a common factor? What is left, it is actually minus 2. And we will repeat on the same process on part 3. So part 3 is 3x minus 6. And the common factor that we will take from 3x minus 6 will be 3. So what is left from 3x after we took from it 3 as a common factor? What is left, it is actually x. And what is left from minus 6 after we took 3 as a common factor from it? What is left, it is actually minus 2. Okay, in total we got that 3x minus 6 equals to 3 times x minus 2. Okay, so now we will substitute those three expressions by those three expressions that are equal to them, and we know that the sum of those three expressions equals to 0. Therefore, the sum of those three expressions also will be equal to 0. Okay, so instead of x cubed minus 2x squared, we will write down x squared times x minus 2, and instead of 2x squared minus 4x, we will write down 2x times x minus 2, and instead of 3x minus 6, we will write down 3 times x minus 2. And we know that the sum of those three expressions equals to 0. As you can see, the sum of those three expressions equals to 0, so the sum of those three expressions will be also equals to 0. So here we will take a common factor of x minus 2 from this equation number 2, and we will get so x minus 2 is a common factor of this expression. So what is left from this expression after we took x minus 2 is the common factor from it? What is left? It is actually x squared, and what is left from this expression after we took x minus 2 as a common factor from it? What is left? It is actually 2x, and what is left from this expression after we took x minus 2 is a common factor from it? What is left? It is actually 3, and all equals to 0. So here we have two solutions possible to this equation number 1. Either x minus 2 equals to 0. If x minus 2 equals to 0, then 0 times anything equals to 0, and we will get that 0 equals to 0. And the first solution is that x minus 2 equals to 0, and the second solution to equation number 1, this equation, is that this expression equals to 0, that is to say x squared plus 2x plus 3 equals to 0. Okay, and if this expression equals to 0, then 0 times anything is 0, and we will get that 0 equals to 0. So actually, this is a quadratic equation. X squared plus 2x plus 3 is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. Actually, x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay, so by using this formula, we will find out the value of x, that is the variable that we are looking for. And here a, b, and c are the coefficients of this general quadratic equation. So in our specific quadratic equation, x squared plus 2x plus 3 equals to 0. Here the coefficients are as follows. In this quadratic equation, the coefficient A equals to 1, the coefficient B equals to 2, and the coefficient C equals to 3. So we will put this data inside the equation for x in order to find out the value of x in our specific quadratic equation. In this quadratic equation. So we will put the data inside this equation for x, and we will get that x equals to minus b, b equals to 2, so minus b will be equal to minus 2, plus minus square root of b squared. B equals to 2, therefore b squared will be equal to 2 squared. 2 squared is 4, minus 4 times A is 1, times C is 3, over 2 times A is 1, so 2 times 1 is 2. So x equals to minus 2 plus minus, here we will have 4 minus 4 times 1 times 3 is 12 over 2. Okay, so actually x equals to minus 2 plus minus 4 minus 12 is minus 8 over 2a over 2. So here we have this expression that x equals to minus 2 plus minus square root of minus 8. But because of the fact that minus 8 is a negative number, and the negative number doesn't have a root, because of the fact that a negative number doesn't have a root, it means that we are stuck here. It means also that this quadratic equation doesn't have a solution, and because of the fact that this quadratic equation doesn't have a solution, we will cancel this possibility. It is not correct possibility because it is not a solution. Therefore, the only solution that is left for equation number 1 is that x minus 2 equals to 0. Okay, so x minus 2 equals to 0. That is the only solution that is left. And if x minus 2 equals to 0, then x equals to 2. X equals to 2. And we have already found out that the radius of the semicircle according to equation number 2 equals to 3 over x. The radius of the semicircle equals to 3 over x. So we will put the value of x inside this equality, and we will get that the radius of the semicircle equals to 3 over x is 2, so it is 3 over 2 units, or we can represent 3 over 2 as 1.5 units. So actually we found out that the radius of the semicircle equals to either 3 over 2 units or it equals to 1.5 units. I will repeat again. The radius of this red semicircle equals to R, the radius of this red semicircle R equals to either 3/2 units or it equals to 1.5 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this red semicircle. We know that we have here right triangle ABC. This angle ABC equals to 90 degrees. Side AB of triangle ABC equals to 3 units. Line segment DC equals to 1 unit. And we want to find out the radius of this red semicircle. Okay, so first of all, I presented to you rule number 1. According to rule number 1 of two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So, what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this blue circle and we have the external point P, and if we draw from the external point P two tangents to this blue circle, so the first tangent will be PA and the second tangent will be PB, then according to rule number 1 of two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So, according to rule number 1, whenever you draw two tangents and to a circle from a common external point, that is to say in this drawing the common external point is point P, and from point P we draw two tangents to this red circle, to this blue circle, then the length of those two tangents will be equal to each other, that is to say PA equals to PB. Okay, so whenever you draw two tangents from a common external point of a circle to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. And we actually implemented rule number 2 in our drawing. In our drawing, we have the external point A of this red semicircle, and from point A we have two tangents to this red semicircle. The first tangent is AB, and the length of AB is 3 units. It's according to what is given us in the question. And the second tangent to this red semicircle is AE, and according to rule number 1 of two tangents theorem, whenever you draw two tangents to a circle from an external point to that circle, like in this case, we have two tangents from point A to this circle, then the lengths of those two tangents will be equal to each other, that is to say AB equals to AE. But we know that AB equals to 3 units, so from this equality we will conclude that AE also equals to 3 units. Okay? Then I presented to you also rule number 2. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So, what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at point O, and we also have tangent AB. Tangent AB is tangent to this blue circle at point M. Point M is the point of tendency. And we also have this radius OM, radius OM, is drawn to the point of tendency. Therefore, according to rule number 2, whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle also will be equal to 90 degrees. Okay, so I repeat on rule number 2 again. A tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So because of the fact that the radius OM is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tendency, then the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And we actually implemented rule number 2 in our drawing. In our drawing, we have tangent AC, that is tangent to this red semicircle at point E. Point E is the point of tendency. And we have the radius OE. This radius is drawn to the point of tendency, that is to say this radius is drawn to point E, that is the point of tendency. Therefore, according to rule number 2, the tangent AC is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So because of the fact that angle OEC equals to 90 degrees, then the green triangle, triangle OEC, is a right triangle because it has one angle that equals to 90 degrees. So we focused on the green right triangle, triangle OEC. In the green right triangle, triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle. I repeat again, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And in the right triangle, triangle OEC, the square of the hypotenuse is OC squared. The square of the hypotenuse is OC squared. OC is the hypotenuse. And it equals to the sum of the squares of the perpendiculars. It equals to OE squared plus EC squared. OC squared equals to OE squared plus EC squared. We know that OC, from this drawing, you can see that OC equals to R plus 1. OE is the radius of this red semicircle and EC equals to X. So we will get that OC square equals to R plus 1 square, OE square equals to R square, and EC square equals to X square. So in total we got that R plus 1 square equals to R square plus X square. We open the brackets on this side of the equation number 1, and we got that R plus 1 square equals to R square plus 1 plus 2R, and it equals to R square plus X square. Here we subtracted R square from this equation number 1, and we found out that according to equation number 1, 1 plus 2R equals to X squared. Then we focused on the right triangles, triangle ABC, and on the green triangle, triangle OEC. And we actually proved that those two triangles are similar to each other. Why? Because, first of all, those two angles are equal to each other. They are both right angles. So, actually, angle ABC equals to angle OEC equals to 90 degrees. And also, angle C, this angle is a common angle. It belongs to both triangles. So we can write down that angle C equals to angle C as a common angle. And also, those two angles are also equal to each other according to third angle theorem. I will repeat again, angle BAC equals to angle EOC according to third angle theorem. So, what is third angle theorem? Third angle theorem states that if you have, according to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. I repeat again, rule number 3 of third angle theorem. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of third angle theorem? The meaning of third angle theorem means that if we have those two triangles, triangle ABC and triangle DEF, and on those two triangles we have two pairs of angles that congruent. Those are the first pair of angles that congruent, they are both equal to alpha, and the second pair of angles that congruent, those are the first pair of angles that congruent to each other. They are both angles equals to beta. So if we have a situation that we have two pairs of angles that congruent to each other, like this drawing, then the first pair of angles must also congruent. That is to say, angle gamma equals to angle theta. And I actually proved that angle gamma equals to angle theta by using the rule that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. In triangle DEF, alpha plus beta plus theta equals to 180 degrees. Here we subtracted equation number 1 from equation number 2. And we got that alpha minus alpha equals to 0, beta minus beta equals to 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we found out that gamma minus theta equals to 0 according to equation number 3. Here we added theta to equation number 3, and we got that angle gamma equals to angle theta, and that is exactly what we wanted to prove. We wanted to prove that angle gamma equals to angle theta, and we did prove that angle gamma equals to angle theta. So we actually proved that if we have two triangles with two pairs of angles that congruent, then the third pair of angles must also congruent. That is to say, angle gamma equals to theta, and we did prove that angle gamma equals to angle theta. Okay? Then we return to our original drawing. And we actually proved that triangle ABC has two angles that congruent with triangle OEC. All three angles of triangle ABC congruent to all three angles of triangle OEC. Therefore, we actually proved that triangle ABC is similar to triangle OEC. This is the sign of similar. Triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle congruent to all three angles of the other triangle, then you actually prove that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC in triangle ABC, AB over AC in triangle ABC equals to OE over OC, equals to OE over OC in triangle OEC, the green triangle. But we know that AB equals to 3 units, AC equals to 3 plus X units, AB equals to 3, AC equals to 3 plus X, OE equals to R, and OC equals to R plus 1, OC equals to R plus 1, O equals to R and OC equals to R plus 1. So in total we got that 3 over 3 plus x equals to R over R plus 1. Here we cross multiply the equation number 2. And we got that 3 times R plus 1 equals to R times 3 plus x. We open the brackets of equation number 2 and we got that 3R plus 3 equals to 3R plus Rx. Here we subtracted 3R from this equation number 2, so 3R will get cancelled. And what is left after we cancelled 3R? What is left is actually 3 equals to Rx. Here we divided this equation by x. It is allowable to divide the equation by x because x can never be 0, because x is one side of the green triangle and it must be a positive number. It can never be 0, therefore it is allowable to divide the equation number 2 by x. So we got that the radius of the semicircle equals to 3 over x. Okay, but we have already found out that according to equation number 1, 1 plus 2r equals to x squared. So we can substitute r in this equation number 1 by 3 over x, because r equals to 3 over x according to equation number 2. So we substituted r by 3 over x in this equation and we found out that 1 plus 2 times 3 over x equals to x squared. 2 times 3 is 6, so we got that 1 plus 6 over x equals to x squared. Here we multiplied this equation by x and we got that x plus 6 equals to x cubed. Here we subtracted x from this equation and we got that x cubed minus x equals to 6. Here we subtracted 6 from this equation and we found out that x cubed minus x minus 6 equals to 0. Here we added to this equation number 1, minus 2x squared plus 2x squared, that equals to 0, and it is allowable to add to any equation 0, therefore we can add this expression that equals to 0 to this equation number 1, and we got this expression. Then we substitute minus x by minus 4x plus 3x. Minus x equals to minus 4x plus 3x, so therefore we can substitute minus x by minus 4x plus 3x, and after we substituted minus x by minus 4x plus 3x, we got this expression. Then we divided this expression to 3 parts, equation number 1 to 3 parts, and we got a common factor from each part. Okay, actually the common factor that we got from part number 1 is actually x cubed minus 2x squared. The common factor that we got from x cubed minus 2x squared is x squared, and what is left from this expression after we took a common factor of x squared is x minus 2. Then we took a common factor of 2 from the second part, that is 2x squared minus 4x. The common factor that we took from 2x squared minus 4x is 2x. And what is left from this expression after we took 2x as a common factor, what is left, it is actually x minus 2. Then we took a common factor from the third part, that is 3x minus 6. The common factor that we took from 3x minus 6 is 3. And what is left after from this expression after we took 3 as a common factor, what is left, it is actually x minus 2. So here, then we substituted those 3 expressions by those 3 identical expressions, and we got this expression. Here we took a common factor of x minus 2 out of this equation number 1, and what is left from x minus 2 after we took a common factor what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually x squared. What is left from this expression after we took x minus 2 from it as a common factor? What is left? It is actually 2x. And what is left from this expression after we took x minus 2 as a common factor? What is left? It is actually 3. So in total we got that x minus 2 equals to x squared plus 2x plus 3 all equals to 0. So here we have two solutions that are possible for this equation number 1. The first solution is that x minus 2 equals to 0, and the second solution is that x squared plus 2x plus 3 equals to 0. Then we focused on the second solution, and in the second solution it is actually a quadratic equation. X squared plus 2x plus 3 equals to 0 is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here, in this general quadratic equation, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x by using this formula for x. So in our specific quadratic equation, the coefficients are as follows: a equals to 1, b equals to 2, and c equals to 3. So the only thing that is left is to put this data inside the equation, this formula, in order to find out the value of x. So here x equals to minus b, b equals to 2, so minus b is minus 2, plus minus square root of b squared, b equals to 2, so b squared is 2 squared, 2 squared is 4. Minus 4 times a is 1, c is 3. So it is minus 4 times 1 times 3. So we got that x equals to minus 2 plus minus 4, and minus 4 times 1 times 3 is minus 12. Okay, so we got that x equals to minus 2 plus minus square root of 4 minus 12 over 2. And 4 minus 12 is minus 8. So we got that x equals to minus 2 plus minus square root of minus 2 over square root of minus 8 over 2. But because of the fact that minus 8 is a negative number, and the negative number doesn't have a root, therefore the quadratic equation x squared plus 2x plus 3 doesn't have a solution. So we abandon this possibility, and the only possibility that is left for the solution of equation number 1 is that x minus 2 equals to 0. And if x minus 2 equals to 0, then x equals to 2. And we have already found out that the radius of the semicircle equals to 3 over x. So we can put the data, we can put the value of x inside this equation number 2. And we actually found out that the radius of the semicircle equals to either 3 over 2 units, because x equals to 2. So the radius of the semicircle equals to either 3 over 2 units, or it equals to 1.5 units. Okay, so I'll repeat again. The radius of this semicircle, of this red semicircle, r equals to either 3 over 2 units, or it equals to 1.5 units. Okay, thank you very much.